Okay, nice. Hi guys. Yeah, review session. You guys know the drill. Uh, I guess for transparency lang, the hardest LE we could find was the last one before the pandemic. I think this is school year 2020 to 2021. But yeah, hopefully it's still somewhat useful. Kasi they stopped sharing the previous LEs though. So yeah, I like last year's LEs. They stopped sharing LE 2 to 4. Okay, cool. Um, so we sent this in the sa ACAD12 channel. You guys can just refer to that. So I'm gonna be using this Samplex 2020. Uh, wait, ay, wait lang. Third long example ito. Advanced. Ayan. Okay. Sige, I guess we can just start. So, problem 1. In a video game, Lance is facing off against an enemy robot who has 100 hit points. So that's this one. Noted na. Lance will attack the enemy until it self-destructs, at which point Lance deems himself victorious. So self-destructs. Yung parang, I guess, win condition of this question. Anytime Lance attacks, there's a 50% chance that he deals 30 damage, a 40% chance that he deals 40 damage, and a 10% chance that he deals a critical hit worth 80 damage. So each point of damage is dealt to the enemy decreases. Each point of damage dealt to the enemy decreases its HP by 1. So it's 1-to-1 lang. In between Lance's attacks, the enemy can take one of 3 actions. The enemy will stand by whenever it has more than 20 HP after Lance's attack. It will heal itself and increase its current HP by 50 whenever its HP is less than or equal to 20 but greater than 0, or it will self-destruct when its HP is 0 or less after Lance's attack. So self-destruct, recall this is the condition before like he wins. So the first thing na hinihingi sa atin is to get the transition diagram and transition matrix that will basically describe this process. So let's just go straight into it. Initial information that we know is that at any state, so you have 40 damage, 50% likelihood, 30 damage, 40% likelihood, 80 damage, 10% likelihood. And then it can do 3 things. The first is do nothing when HP is greater than 20. Heal when HP is greater than... Is my pen bugging out? Sorry. Heal when HP is less than 20 but greater than 0. And then self-destruct when HP is less than 0. Less than or equal to 0. Okay, so given that, I guess the way we can just start it off is to just, from this information, how do we make yung state diagram? I guess there are 2 ways. The first is we can play around with it and just try to exhaust every possible scenario. So what do I mean by this? From there, we just assume the states kasi we can like basically parang go through every possible scenario. And then if there are repeating scenarios, then we can just like stop going down that path kasi we've already discovered na yun yung pwede na ano. So in this case, start with 100. Just don't put probabilities into it muna. Like just think of the scenarios, right? So you have 100. Pwedeng from that point, pwedeng mabawasan siya ng 40, 30, or 80. Yeah, tama. So then, yung possible hit points na is magiging 70, 60, or 20. But recall that every time the enemy has 20 or less hit points but greater than 0, it'll automatically add back 50, right? Kasi it'll heal itself. So that means that we're back to 70. So we know, therefore, that from the state 100 hit points, it can only either go through 60 or 70. These two, because we're only concerned about the state, right, and not how they got there. Kasi like, if you think about it, we can essentially represent T equal. We can set T as 1 cycle of damage from Lance, of damage from Lance plus the appropriate response from the enemy. So yun yung parang one cycle of time mo. That's your T equals 1. Right? So isang cycle, isang damage, like isang damage from Lance, isang response from the enemy, right? That means na consistent, like at the start of parang your state is basically before they do that exchange, where Lance does something and then the robot does something. So that's just that's a bit confusing, sorry, pero I hope that makes sense na these two scenarios you can treat as the same. So those are fundamentally the same states. So from 100 can be 60 or 70. We repeat the same process. So from 60, you can either deal 30 damage, so magiging 30. And as a response, since it's greater than 20, the robot does nothing. Pwedeng from 60, you deal 40 damage and becomes 20. We found out from previous that just means na mag-respond yung robot by healing itself, becomes 70. Or deals 80 damage, so magiging negative 20, which is less than 0. So the game ends, or the video game ends, the robot self-destructs. So yun yung alam natin mangyayari from 60. So it's either the case it's going to be 30, which is a new state, becomes 20, the robot responds by healing itself by 50, magiging 70, which is the same as what we've previously discovered, or the game ends. So yun yung 3 possible states that are connected to 60. 30. So from 30 naman, if you notice, 30, you deal 30 damage, magiging 0. You deal 40 damage, magiging negative 10. You deal 80 damage, magiging, what is that handwriting? Negative 50. Sorry. So, yan. Oh my God. Yan. So, we all know, regardless, that means the game will end. So, ayan. Na-exhaust na natin. So, balik tayo dito. So, right now, as of what we've done, we've identified na the possible states are 100, 70, 60, and 30. And then yung 0, where the game ends. Let's look at naman yung 70. So from 70, yung pwedeng mangyari is, you deal 30 damage, maging 40. You deal 40 damage, maging 30. You deal 80 damage, maging negative 10. So this is the end like scenario. So we established na that just means the game ends. Pero the other two options are 40, which is new, and 30, which we already know what happens kapag 30 yung mangyayari. So we don't need to like investigate further doon. Dito naman 40, 3 things can happen. The first is that it will deal 30 Lance will deal 30 damage, so magiging 10 siya. That's less than 20 but greater than 0. So as per the problem, the robot will regenerate 50 hit points, so magiging 60 siya. And we know already what happens when it has 60 hit points. Like, we know what are the following states that are connected to it. Pero if it deals 40 damage, magiging 0. If it deals 80 damage, magiging negative 40. The game ends. So at this point, we know what previous state leads to the next state. Kasi na-try na natin lahat. We've pretty much exhausted every possible scenario. So that means na we know that our states are 100, 70, 60, 40, 30, and 0. So that's one way to do it. The other way is to just brute force it. So if you look at it, all the hit points and the damage and whatever, increments of 10 sila, right? Or they're all divisible by 10. So we know na from that, the possible hit points na you can have is just from 0 to 100 by 10, right? So that would look like this. So sige, I can go through this one by one naman. So from 100, you can either deal 30 damage, 30 damage, 40 damage, 80 damage, right? So it's either magiging 30 siya, so that's 70, or magiging 40 yung damage, so magiging 60, or magiging 20. But if you notice, walang 20 or 10 dito, because as per the problem, if the robot's health is like is 20 or 10, so less than 20 but greater than 0, it will regenerate. So meaning you cannot possibly have a scenario, given that we set one increment of T to be one cycle of damage from Lance and then the response of the enemy. So we cannot have, it's not possible to have 20 and 10, right? So that's why napunta dito yung 0.1. So this is 0.5 plus 0.1. Because when it goes to 20, so yung nakita natin dito, when it goes to 20, it becomes 70 because of the way the problem is set up. We apply the same things here, kaya siya nagmo-move lang by 1, right? The pattern breaks at 60 kasi there's a 0.5% chance na you deal 60 damage. You deal 30 damage. So 60 magiging 30. There's a 0.4 chance that you deal 40 damage. So yung 60 magiging 20 plus 50 magiging 70. That's why it's here. And 0.1 chance na you deal critical damage, which is 80. So 60 minus 80, negative 20, magiging ito. And then the pattern just basically resets and continues. So kaya dito 0.5, 0.4, 0.1. This is 0.5 kasi 50 damage, 50, 30 damage. So naging 20 siya plus 50. So that's why it's here. And then same reason here. The last thing in this like transition matrix is na for 30 and 0, well, for 30, diba, as we've established dito, kung 30 yung hit points mo, no matter what happens, you will reach less than or equal to 0. So regardless, 0 yung final state niya. So the game ends. Here naman, 0 just stays 0 because if you're dead, then the game ends. So never ka makakalabas sa state na yan. So once we plot that, this is what it'll look like. So just applying the appropriate probabilities to each. Yeah, okay. I hope that makes sense so far. Pero, so what's the distinction between the two? Kasi diba, nakita natin dito na 170, 60, 40, 30, 0 lang yung lalabas. Yung possible states for this problem. For this one, we were able to find 90, 80, and 50. So, which one is correct? Technically, both of them can be. But in the context of this problem kasi, right? The implication when you say that the game, in the video game, you have an enemy robot, it has 100 hit points. That implies that the starting state here is 100, right? If you look at the state diagram, there's no way for you to get to 100, get to 80, 50, and 90 from 100. Because if the starting state is here, so like mag-travel ka between all the states, you cannot get to any of these states, right? Meaning, in the context of this problem, it's as if these states don't exist, right? So meaning, effectively, the only like relevant part of the state diagram here is really just the part that refers to the states written in black. The ones written in blue, you cannot access those states from 100 as your starting state. So therefore, parang removing the redundancies, magiging ganito lang siya. So that's the transition diagram. The transition matrix naman, you just remove 90, 80, and 50 from this one. So effectively, see, I'll just also take that now. So effectively, what you end up with is, I wrote it down here na pala, is this. So this is your transition matrix. The rest are zeros. Hindi ko na sinulat para it doesn't look messy. Yeah. So that's 1.1.1. So that's the transition diagram and transition matrix. So, okay. That's basically the first part. The second part is it asks us to set up the system of equations that will give the steady state probabilities of the process. Wait, sorry. Before we continue, are there any questions? Wait. I'll check lang if meron.
I have a question.
Go lang.
Is the reason why you didn't include 20 and 10 already in the matrix because you're already assuming that it won't reach there, and then you're already adding the healing value.
Yes, kasi for if it's a discrete time Markov chain kasi, the assumption is, diba na, the assumption is like, wait, ano yung notation? Let me try to remember. Probability of x at time t given x time minus 1 is equal to, so like basically the probability of the present thing given the thing that happened 1 unit of time ago is equal to this xt given xt minus 1 x t sorry, let me rewrite that. Xt minus 1 xt minus 2 etc. Kasi, so yeah, but this is like the Markovian property, which is like the thing that will happen, or the thing that is happening is dependent on the thing that happened 1 unit of time ago. For that property to hold, you have to have a consistent basis for what the unit of time is. So that means na you have to lump in together yung cycle of Lance doing damage to the robot and the robot responding accordingly. So yung pwede siyang mag-standby, heal itself, or self-destruct. You have to lump them in together as 1 unit of time. Kasi if you're not lumping them in together, so mag-alternate sila, your units of time are now different, or like the thing that can happen at that unit of time is different, right? So for the Markovian property to hold, the thing that is happening in that unit of time has to be consistent throughout, which is why there is like, for the purposes na you define T as like 1 cycle of damage from Lance and then the response of the robot, wala talagang 20 and 10, because when it is 20 and 10, the robot responds to it. So like I guess you could think about it as like deep inside the transition, my 20 and 10, but you don't see it because you're taking discrete like snippets of time. So from one cycle to the other, like basta di mo siya quote unquote di mo siya ma-detect in a way. So yeah, that's I guess the I think I made it more complicated. No? Sorry. Basta di mo siya makikita kasi you don't check the state before the robot responds. You check the hit points after the robot responds. Kaya ayun. I hope that made it less confusing. Did that answer the question naman?
Yeah. Thank you.
Okay, nice. So yeah, that's basically for the first part. For the second part, steady state probabilities of the process or the system, and then it makes us solve it. So let's just do it sabayan. So there are 2 ways to do this. The first is just the manual solving, and then the second is like using concepts. Okay, let's just do manual first. So here's your steady state diagram. Here's your transition matrix, and we're looking for the steady state. So just recall na in case like you might need to remember it. Like if you forget during the exam, you need to remember. You're essentially just multiplying. The property we're looking for the transition probability is just t. It's essentially just, so this is your t, just regular t, your 1-step transition, meaning this gives us the probabilities that like where you given your current state, what is the probability you'll end up, what is the probability of like states that you can end up with in 1 step, so in 1 increment of t. Conceptually, steady state probabilities are basically just t raised to infinity. So you're taking the matrix T and multiplying it by itself an infinite number of times. Obviously, we don't do that manually because it's impossible. So what we do is essentially find T sub pi, and this has the property na like when you multiply it by a 1-step transition matrix, it'll still be equal to itself. So I guess, in case di pa siya super automatic, right, at least you can find a way to like re-remember it and derive it sa exam. So what that means is you're essentially just, oh my god, ugh. You're essentially just multiplying it with a square matrix also of puro pi. So pi 100, what are our states? Pi 100, pi 70, pi 60, 70, 60, 40, 30, 0, 60, 40. Okay, so I only wrote one row, and the reason for that is across the whole square matrix, this is just the same. So multiplying these two should be equal to the matrix itself. Right? So yan. So that's basically like steady state, right? That's the theory behind it. So this should give us the probability the probability that in any given point in time, a certain thing is at a certain state, or the process is currently at a certain state, right? So yeah. I hope this part is especially clear. If it's not, like, feel free to let me know. But basically, that's like the inner theory for steady state probabilities. Solving it now manually. So you have the following system of equations. So how did we get to this? So essentially, multiply natin. So I guess just small recall of matrix multiplication, no, from 40. So this row, this column, you multiply it with this row, right? So this row multiplied by this row multiplied by this row, etc. So like uulit lang yan na process. What you should get, wait, yeah, what you should get is this. Okay. Before that, I just want to confirm, like that part makes sense naman, no? Or do you guys would you guys still prefer na I like do it step by step? But I'm assuming this is like okay na. No, like no shame, guys. Like if you guys want me to do it step by step, it's fine. But this will take a while. So if you guys are okay to just like if gets you na how to get to this part, I will just continue on. But if hindi, let me know. So I will assume na like because this part is like basically just matrix multiplication, right? So we can just I guess continue to like the thing itself. So after you do that part, you'll get these systems of equations. So that's the answer to 1.1.2 na, right? So the next thing we want to do is try to extract as much information as possible before we like have to plug in. Kasi the likely scenario sa exam is they will force us to have more than four simultaneous equations. Because if you have four, you can just do it kasi sa calc. So they want it to be difficult, obviously. So we have here 1, 2, 3, 4, 5, 6, 7, including including the normalizing equation, which is basically like all the steady state probabilities, they have to add up to 1. So we have 7 simultaneous equations, or we have we have 7. So the first information that we have is that pi 100 is 0. Why is this the case? Because like pi 100 is equal to this, right? This times this row, this column multiplied by this. So obviously mag-zero yan lahat. And that's equal to pi 100. Yeah, that's equal to pi 100. So meaning just this becomes 0, right? And if you think about it, that makes sense. Why? Because if you start at 100, you can either go to 70 or 60, but you can't come back to 100, right? It's essentially not essentially, it is a transient state. So meaning it makes sense that its steady state probability would be 0, because you're never gonna come back to it once you leave it. So in the long run, the probability that it's at 100 is just 0, or just trends towards 0. So that makes sense. What that means is now we can cancel these two. So now it just simplifies sorry. It just simplifies our like thing down even further. So yeah. It simplifies it even further. So now we just have 1, 2, 3, 4, 5. So we still have 6, pero wala na to. So now the next thing we want to do is try to isolate some equations now we can use simultaneously. In this, so like this is a bit of like just checking which combination of equations to use. So let's just start with pi 70, the equation for pi 70. So that's pi 70 equals to 0.4 pi 60. So that we have two equations. We have one equation, two unknowns. So we can't solve for it yet. So let's try adding another one. That gives us pi. So itong pi 60 equals 0.5 plus pi 40. So we added one equation, but they also added one unknown. So two equations, three unknowns. Still can't solve for it. So we have to add another one. Let's try adding something with pi 40 para hindi, if we add that equation, there's a chance that we don't add that many unknowns. So let's add the one for pi 40, and that's equal to 0.5 pi 70. So now we only added, so we added 0 new unknowns, but we added one new equation. So that balances it. We have three equations, three unknowns. So that means na we can solve for it, right? So taking these three as a system of linear equations, you can plug this into your calc, pero essentially yung lalabas is these are all equal to 0. And then, so yeah, that's equal to 0. And because by using this equation, since we know that pi 70 and pi 60 are equal to 0, this whole term just becomes pi over 30. I'll just write it down. 1, 2, 3. By equation, using the info from here, by equation 5, essentially what happens is you have pi 30 equal to 0.4 pi 70. We know this is 0 because pi 70 is 0, and 0.5 pi 60, 0. So magiging 0 din siya. Yeah, so pi 70, pi 60, pi 40, pi 30 is 0. So 70, 60, 40 is 0. So 100 is 0, 70 is 0, 60 is 0, 40 is 0, 30 is 0. And that therefore means the equation that we have left is this bottom equation, which is like, since all of them have to add up to 1 and everything else is 0. Oh, shit. Wait, yeah. Since all of them are basically 0, right? Because we've solved for this. The probability of pi 0 is equal to 1. So that's basically the answer to this. That's the steady state probabilities. But why is this the case? So the shorter way to solve this is just through concepts. So if you look at the state diagram, state 0 is absorbing, right? Why? Because it basically just loops in on itself. Because when the robot dies, diba, the game ends. That's what the problem says. So meaning you can't really go back to the other states anymore because the game stops. So meaning just to have a closed state diagram, you have to loop it na mag-loop lang siya. And if you end up in 0, there's no way for you to go back to 30, 40, 70, 60, let alone 100, right? What does this mean? This means that because there's a chance that you can't go back to 40, 30, 70, 60, and that chance happens when you end up in state 0, the rest of these are also transient. Because these are all transient, right? So the class containing 100 and the class containing 70, 60, 40, 30 is transient. all transient states just have steady state probability of 0, and then the sole absorbing state has a probability of 1. So that's just how you solve it using concepts. So yeah, much faster, right? Kasi these are all just known, like these are intrinsic properties to Markov chains. So yeah, that's for 1.1.2 and 3. The last thing asked from us is to set up the system of equations that will give the average number of attacks Lance will need before the enemy self-destructs. So this one is just mean time before absorption. The reason for that is the enemy self-destructing, as we found out, is an absorbing state. The reason why it's an absorbing state nga, diba, is when it self-destructs, the game ends. Meaning, we had to set it up in the Markov chain as an absorbing state. So, therefore, we can just use mean time before absorption, the average number of attacks, and we establish that one increment of time is the number of attacks, right? So yeah, yun yung for mean time before absorption. So, setting it up accordingly, just recall na the equation for mean time before absorption is just the mean of the starting state. The mean time before absorption is just 1 plus the probability of an adjacent state. So meaning the probability from the starting state to an adjacent state multiplied by the mean time before absorption of that adjacent state. So this is just like, I would say, my personal unconventional notation for this. And then you just add these all together. So that's what we did here. Wait, I'll try to make this easier to look at. Wait, sorry. Okay. So, yan, para may reference tayo. Okay, so the very first thing we need is the main objective we're trying to solve, diba, is the number of attacks before the game ends. So that's just mu 100. That's equal to 1 plus what's 100 connected to? States 70 and 60. Probability is 0.6 and 0.4 respectively. So we just plug that in. Probability to go from state 100 to 70 is 0.6. So 0.6 times mu 70. And then the probability to go from state 100 to state 60 is 0.4. And then you just have mu 60 here. So this is technically the only equation that, this is the main equation that you're solving. Pero, ayun nga, we have to set it up as a system because we have one equation but 3 unknowns. So we want an equal number of equations and unknowns. So there are multiple ways to go about this, but for me personally, the fastest way from doing practice is taking one of the unknowns here and making it the left-hand side. So this case, let's try mu 70. So going back to our state diagram, state 70 can go to 40. What was that? Yeah. 40, 30, or 0. So 0.5, 0.4, 0.1% chance respectively. So that means na going back here, mu 70 is equal to 1. Just like laging may 1 plus pag mean time. And then 0.5 mu 40. The reason why may gap siya is personal preference lang. Same like unknowns in the same column para madaling basahin. 0.5 mu 40 plus 0.4 mu 30. Right. Probability lang to go from 100 to 40, 70. 70 to 40, 70 to 30, and then 70 to 0. But recall also na since 0 is already an absorbing state, the mean time to get to an absorbing state from an absorbing state is 0, right? So if you're already at 0, which is an absorbing state, the mean time to get there is 0. So maka-cancel natin yan as just 0. So we don't add on to our number of unknowns. Unfortunately, what this means is that for us, we've added 2 unknowns and only 1 equation. So we now have 2 equations and 4 1. So naging 5 unknowns siya. Wait lang. Yeah, 5 unknowns, 2 equations. So okay, let's try naman adding mu60. So mu60, going back to our state diagram, this can either go to mu70, 0, or 30. Yeah. Looking at that just means you have 0.4 chance going to mu70, 0.5 chance of getting to mu30, and then 0.1 chance of going to mu0. We cancel this term out as 0 for the same reason as we did this. The mean time before absorption from the absorbing state is just 0 because you're already there. So ayan. Now we have 3 equations and we didn't really add any unknowns. So that's quite good. So but we're still 3 equations, 5 unknowns. So we still need to add one more. At least one more. So let's try mu40 because we've expressed mu70 na mu60. Trying mu40 naman. Can either go to 0 or 60. 0.5 chance each. So just represented as such. Mu40 is 1 plus 0.5 mu60 plus 0.5 mu0. This is cancelled out as 0 for the same reason. And then, yeah, 0.5 mu60, 1 plus dapat. Okay, so now we have 4 equations and di pa rin nagbago yung number of unknowns. So 4 equations, 5 unknowns. So let's try one more. That we haven't expressed pa is mu30. So let's derive an expression for mu30. Mu30 from state 30, you can only go to state 0. So what this looks like is mu30 equals 1 plus technically my 1 dito. Yeah, I'll just add it for the sake of my 1 dito. 1 times mu0 is 100% chance. Again, that's just 0 because the mean amount of time to get from I think I've said that like 3 times. So yan. So now we have 5 equations and 5 unknowns. But we can easily see it's quite intuitive because na-cancel to, diba? So 0. So this is the only term. So this is solvable, right? Mu30 equals 1. Like that's literally just it. So now we know mu30 is equal to 1. And now we can plug that in here sa dalawang to. We can plug this in. Mu30 is equal to 1. This makes sense when you look at the state diagram because the mean amount of time it takes to go from state 30 to 0, it'll take an average of 1 step, right? Because the only place 30 can go to is 0, like 100% chance, and it takes 1 transition. So that makes sense intuitively and like mathematically also. So now mu30 equals 1. So we can plug that in. And then now we have 4 equations and 4 unknowns using equations 1, 2, 3, and 4, right? So what I did here is, okay, I'll just demonstrate it for one equation and then it follows naman for the rest. Copy. So what I did here essentially is, I just transpose this to the left. So maging -1 equals -100 mu100 plus 0.6 mu 70 plus 0.4 mu 60. So this is just what I did here. Yan. So that's basically how to just set it up, and then I just did the same for the other 4 equations. So this is just like just moving it all to one side so you can input it sa calc. Once you solve for this, you will get the following. So these are basically the steady state probabilities. But the only one that really matters to us here is mu 100, the mean amount of time it takes to go from state 100 to the absorbing state, which is state 0. And this is essentially 3169 over 100 over 900. So that's the mean amount of time it takes. For those who followed along and solved, so that's approximately 3.521 repeating. I'll just add that. Okay. So that's basically the average number of attacks Lance will need before the enemy self-destructs. Yeah. So that's for problem 1. Before I proceed, are there any questions? Or clear naman? If to the person who messaged here sa I can't click it. So, yeah. Okay. I'm gonna assume that was sufficiently okay naman. So, alright. Moving on to the second problem. Wait, check ko lang sa messenger. Sorry, I'll just keep it on a separate device. Pero mukhang wala naman. Okay. Okay, cool. Problem 2. So, may true or false dito. So, let's just go through the concepts quite just like briefly. Okay. So, for the following statements, write true if correct, false if otherwise, prove a one-sentence explanation or counterexample. So, 2.1.1, all recurrent classes are absorbing classes. This is true. So, I think the one thing you might like overthink on is what about irreducible classes? So, in that case, it is still like a recurrent class would still be absorbing. Because, for example, if you had this, like if you had a Markov chain with one state, it's absorbing and it's recurrent. Like even if that's the only thing you see. Because hypothetically, if you added another state, let's say B prime, into it, you would see that it's absorbing. And it's also recurrent because it's like you can always get back to A from A, right? Even though it's just looping in on itself. So yeah, that is true. All recurrent classes are absorbing classes, even if they are the only class, because that just means that like basta by just some weird definition thing. Okay. I think one other confusing thing is when it comes to states, because not all recurrent states are absorbing states, but all recurrent classes are absorbing classes. So I guess it's just important to take note of that distinction. The second one is all states in a discrete time Markov chain can be transient. This is not true, and the reason for that is at least one has to be recurrent or the whole chain has to be recurrent. That makes sense. Kasi, diba, the definition of a transient state is that you can never get to go to it again, right? Meaning na the process has to go somewhere that isolates like that state. So for example, if you have like state A, it needs like somewhere to go to, like let's say let's suppose that state B and C, right? So if you have B and C, like they have to communicate with each other in a way na ma-isolate mo si A. And by doing that, right, you create a recurrent state, basically. So either one has to be recurrent, kasi then you can create as many transient states as you want. So let's see, this is also transient kasi they communicate with each other. Pero, sorry, not B and C. D, E. Because they can communicate with each other, right? Pero so long as there's a chance that D goes to B, there's no way to come back to D and E, right? So you can like stack as many like transient states or transient classes, but you need at least one to be recurrent because that's where all that's where the process all goes to, like in the long run, or the whole chain is recurrent, which is just like what's that? Yeah, the whole chain is recurrent. So wala kang transient state because the whole chain is recurrent. Yeah, so that's for 2.1.2. This is false. For 2.2, is it possible to compute a unique mean of first time passage for a system with multiple recurrent classes? And then why or why not? The answer is no. The reason is um suppose we get the mean amount of time to go from A to C. So mu AC. Um so we have to get the average of like the chance of A going to C and how long that takes. And then from A, but like there's a chance kasi now we can't get to C. So for example, if our process starts at A and because it's 50-50, it goes to B, there's no way for you to go to C. Meaning the quote unquote the time of first passage from A to C going through B is technically indeterminate or infinite, right? Because it's like because this is absorbing. Oh, because this is absorbing. There's a chance now if you end up in B, you can just never go to C. Because you can never go to C. There's no mean amount of time to go to C. So that's basically why it's not true. For 2.3, is it possible for a transient state to have a non-zero steady state probability? Why or why not? So here's one example of just very simple Markov chain showing like so A is our transient state, right? Because there's a chance that it goes to B and it will just stay in B because B is an absorbing state. So recall na our steady state probability is effectively just the transition state multiplied to infinity. So I guess I just computed like the t raised to n of like very large iterations. Obviously you don't have to do this, but this is just to demonstrate na as time goes on, the chance that they end up in state B becomes larger and larger. Kasi yes, malaki yung probability na like A just loops on itself. But the moment it goes to state B, there's just no way to go back to state A. So yeah, we expect therefore na over time, magiging, because as the process runs like over long periods of time, or if you repeat the process multiple times, it all just ends up in B. So the likely, like yung sa number of families example in class, you just end up having no families or you end up having nothing here at state A. So the steady state probability in that case is basically 0. So this applies for all transient states because that's the thing with transient states. It doesn't matter like how many steps it takes. There's a chance that you cannot come back. So if you let that process run like to infinity, you will just run out of times where you enter that process, or eventually it will leave the process. Kaya siya magiging 0, yung steady state. That's for 2.3. Okay. Moving on to 2.4. So this is the Markov chain, states 1 to 7 with the following transition probability matrix. Okay. So that's states 1 to 7. Currently, the variables A, B, and C are unknown. Assume that the column arrangement is similar to the order of the rows, left to right, state 1 to 7. So what constraint should A, B, and C follow so that the given is a valid transition matrix? So this is just drawing the state diagram for this. So no added calculations pa. This is just us converting the matrix into a state diagram and making some basic observations. So na-observe natin, like from making that 3 is absorbing, because there's no way to get out of 3. 6 is transient because there's no way to enter 6. Eventually, we also observe that 5 and 4 are transient because if you group them together, there's no way to get to this class from outside. From outside. So meaning eventually lalabas lahat ng papasok kay 4 and 5 and there's no way to get back. So it's transient. And then 1, 2, 7 are recurrent. Right? Because there's a way to get back like to each other from any point in the this class. So okay. Those are just some initial observations. Going back to how we solve for A, B, and C. For this to be a valid transition matrix, the rows basically just have to add up to 1. So in this case, it's just taking all the values that you see along the row and adding them to 1. So row 5, 0 plus 0.125 plus A plus B plus 0.25 equal to 1. And then A plus B, therefore, like just moving it around, is equal to 0.625. So this is the final answer na. Like, because there's no way to solve further pa. Basically, both of them just have to add up to 0.625 such that both A and B are non-negative. Right? Because it can't have negative probabilities. The same process is true for C. So 0.29 plus 0.41 plus C is just equal to 1. Solving that, you just get C equals 0.3. So that's basically for 2.5.1. Just the constraint is 2 is accessible from 1 and so is 7. So yung next ko na Druno. And then because I have 2 and 7, I checked which states are connected to 2 and then I did that muna. And then I did 7, etc. And then so basically like in order, ito yung naga 1 then 2 then 7 then like 1 then 2 then 7. So then I found out na there were no other states that connected or like that parang na-exhaust ko lahat going through that. So then that gave me the suspicion that this is probably one class. So then I tried with 3. Found out that 3 only loops back to itself. So nalaman ko na it's absorbing, etc. And then you just repeat the whole process. So yeah, there's really no one way to do it kasi it's really based on like just carefully are communicating with each other. So yeah. I hope that's still somewhat helpful though. So yeah, just going back, summarizing the result. 3 is absorbing, 6 is transient, 5 and 4 are transient, and then 1, 2, 7 are recurrent. Okay. So that's for 2.5.2. For 2.5.3, given that A, B, and C are all greater than 0, identify the periodic classes, if any. So recall, periodic classes are basically classes that are like, they have a fixed, they take a fixed amount of time to return to each other. Okay. So for example, wait, sorry. Ba't ngayon pa? Yan. So very simple example. The amount of time it takes to go from A back to A is always 3. Right? The amount of like increments. 1, 2, same with B. 1, 2, 3. Same with C. So meaning this is a periodic Now, this is periodic with t equals 3. So as long as you can find a pattern where it returns to itself, and the clarification here is, when you say t equals 3, that doesn't mean that it always returns every 3 times. It can mean that it returns, let's say, at time 3, and then at 6, then wala siya at 9, and then at 12, babalik siya. That's still periodic with t equals 3. It just means na the time it takes for it to return is a multiple of that number. So, okay, here's an example of that. A, B, C. So let's suppose A and B, and then yan. So here naman, right? Going, let's arbitrarily start at C. So C, 1, 2, 3. Ay, wait. Yeah, tama. Wait. 1, 2, 3. Ay, wait lang. 1, 2, 3. Wait, kailangan pala ng isa pa. Right, so, basta essentially, like, wait, does this example make sense? Wait lang. Okay, I don't think this is a valid example pala, sorry. Pero, can't visualize it right now. Pero basically, the period, pag periodic siya, is the process will only return to that state at a multiple of that, but not at every multiple. So, in this case, it can return at t equals 3, 6, and 12, but not necessarily 9. That's okay, because that means na it will still could potentially return every t equals 3 na multiple lang. So yeah, that's the first thing. The second thing is that obviously it has to be recurrent, right? Because for you to have a fixed amount of time to return, you need to be able to return in the first place, like with 100% certainty. So meaning if you're transient and there's a chance that you won't come back, um, automatically hindi na possible na maging periodic yung transient. Hindi na rin possible yung absorbing because periodic requires that the T is 2. If you are absorbing, you will return to yourself all the time at an increment of 1. So your T is always 1. Your T of like your mean time before you return is always 1. So meaning automatically di na siya pwede. So that means that our only candidate for periodicity is 1, 2, and 7. So if you take state 1 for example, the paths to go from state 1 to state 1 back again is as follows. Pwede kang mag dito. So that means the time it takes is 1. Pwede kang mapadpad dito. So 1, 2, 1. So that's 2 steps. And then that can repeat, right? So pwedeng 1, 2, 1, 2. Ulit-ulit. So that can repeat. Pwede ring 1, 7, 1, 7, 2, and then back to 1. And then again, you can keep looping there. So since they're common, like wala silang common na multiplier, so it's either you return in 1 step or in 2k steps or in 3 plus 2k steps. Wala siyang, like numerically, wala siyang GCF, and there's just no common multiple that you can add the return times by, and therefore it's aperiodic. So this means since our only candidate for periodicity, which is the sole recurrent state dito, because again, automatic hindi na to pwede. We have no periodic classes in this Markov chain. Yeah. So that's for the second problem. Are there any questions? None naman. Okay. I will assume there are none. Sige. Okay. Problem 3. So more true or false. Okay. If the mean times both exist, the mean time of first passage from state K to an absorbing state is always equal to the mean time before absorption from state K. So basically, kung may mean time of first passage ka to state K to an absorbing state, is just the same as mean time before absorption from that same state. So it's like you have K, and then you have some state A prime that's absorbing. Like there's a whole Markov chain in between. Pero yan. Is the mean first passage time to that state the same as the mean time before absorption? The answer is true. One potential concern is that what if dalawa yung recurrent? Because if you think about it, pwede kasing may state K ka dito. You have state A, which is recurrent, which is an absorbing state. And then you have state B, which is also an state B, which is also an absorbing state. Paano yan, right? Because obviously, ayun nga, as we previously discussed, pwedeng maging infinite yung mean first passage time dito if you're taking the mean first passage time from K to A. But the problem says assuming they both exist. So in a scenario like this, you cannot calculate for the mean first passage time because of what we mentioned here. Because of what we mentioned here, there's no way to calculate for mean first passage time for a Markov chain like this. So since the problem assumes that they can both exist, this scenario only applies when you have one absorbing state. So therefore, the mean time before first passage is the same as mean of time for first passage is the same as the mean time before absorption when there is one recurring state, one recurrent class or one like absorbing class, right? So meaning this is true. That's the important part. So that's for 3.1.1. For 3.1.2, given any Markov chain that consists of only one class that is periodic with a period K, the MTFP from one state to any other state in this Markov chain should also be a multiple of K. This is false if you look at mean recursion. What do I mean by this? This means na kasi if you have a Markov chain that consists of only one class and it's periodic with period K, the MTFP from okay. Yeah, basta this is false because let me just double check what I wrote down. Kasi the period basically is the time it takes to go from the class you're starting at back to the same class, right? Meaning, like let's say if you have A, B, C, so very simple na Markov chain, and we know this has a period of 3, right? Because it's like 1, 2, 3, and then the same is true for B and C. So this only tells us that the time it takes to go from A to A again is 3. But that doesn't mean that the time it takes from, let's say, yung sabi dito, from one state to any other state. So let's say A to C. This will obviously happen into like in 2 transitions, right? So it's not a multiple of 3. Same thing with A to B. Because yung period mo tells you the mean recursion, not the mean time before first passage. Right? Okay. Yeah. So that's
parang it's a very small semantic trick lang. Pero essentially, period tells you when it's gonna come back to itself, not how long it takes to go to another state. So yeah, uh, that's 3.1.2. For 3.2, so this another word problem. So a particular tournament for a sport played with three opposing teams per game is ongoing. For the final round of the tournament, a team must tally two consecutive winning games before being declared the champions. So this year, the milk teas, coffees, and sodas are competing in the final round. The probabilities of winning any game are constant at 1/2, 1/3, and 1/6 for milk teas, coffees, and sodas respectively. So given the winning rates, how many games is expected for the tournament? So that's the first part. For so this is essentially just mean time before absorption, right? Because the tournament ends when somebody wins twice, meaning the end condition is a 2-win streak, right? So meaning if somebody wins twice, the tournament ends and wala nang mangyayari. So that's your absorbing states. So because we want two consecutive wins, not necessarily from any of the teams. So any of the teams, if any of the teams win twice, um edi tapos na yung tournament. So we can model that as like one absorbing state per win condition depending on the team. And then we can model this as like the probability they'll win once and then the probability that they'll win two in a row. So that looks like this. So you start from zero. So zero just means walang may win streak. And then let's first focus on one lang. So let's start with milk teas. It makes sense. 1/2 probability na sila yung manalo in the first game, right? And that means na after they win once, they have a win streak of 1, which makes sense, right? So then from this position, if they win again and the probability of winning is 1/2 ulit, then they reach 2 wins in a row and they win the tournament. So ulit. Um so essentially, if you look at it, it's this we used apply the same logic for the coffees and the sodas. So kaya siya symmetric tignan because it's the same logic, different probabilities lang. What about yung sa gitna? Um, like what about these ones? So imagine now, nanalo yung milk tea sa first game, right? But there's a chance that they lose. So let's say, for example, if they lose and it's the coffees that won, because the probability of them winning any game is constant. Any like game is constant regardless of the win streak, diba? So 1/3. So may 1/3 chance na yung coffees mananalo. And when the previous winning team loses, the current winning team doesn't start back at zero. This is the mistake that I made when I first did this. It doesn't start at zero. It starts at 1, pero nalilipat sa kabilang team yung win streak of 1. Right? So meaning, you have a 1/3 chance that you go to C1, where basically the coffees have a win streak of 1. So this is why you have 1/3 here, 2/3 here. So the opposite scenario is true. Coffees have a 1-win streak. Milk teas have a chance, 1/2 chance of winning the next game. So then 1/2 to there. So ayan, this is basically the state diagram for this. So now that we have a state diagram, we can just take the mean time before absorption, and this is the setup for that. Okay, I'll just run by this a bit more quickly this time. So again, our main concern is from 0 to any absorbing state. So it's just taking mu0 is equal to 1, which is always included, and then 1/2 mu m1, right? 1/2 because it's adjacent, and then 1/3 times mu c1 because it's adjacent then, and 1/3 chance to get there, and then 0 to s1, 1/6 chance mu s1. So same process. We have one equation for unknowns. So let's try to get an expression for m1, which is the following. Exact same logic lang. The only thing worth noting here is that you have a 1/2 chance from going from M1 to M2, but M2 is already an absorbing state. So it just cancels out to 0. Yeah. So now this is our two equations and four unknowns. So again, let's try expressing another one. C1 gives us another equation. So ganito lang siya. The same logic applies. And then S1. So this is now 3 equations, 4 unknowns. Yeah, 4 unknowns. And then adding S1 makes it 4 equations, 4 unknowns. So we can now solve that. And because most calculators kaya up until 4 simultaneous equations, you can just solve it as is. And that's the numbers that you will get. So that's the amount of games expected for the tournament. So this doesn't tell us yet like which team will win. It just tells us na this is the amount of games on average bago mag-end yung tournament completely because may nanalo na by winning twice in a row. So now, that's for expect like mean time before absorption. The 3.2.2 naman asks, what is the probability that the coffees win the tournament? Okay. The coffees win the tournament. So essentially what we are interested in is the probability that if we start here, we end up in C2. So F0 to C2. This is just equal to, again, I mean, this is the pattern naman for probability of absorption, mean time before first passage, and mean time before absorption. Probability of you going from the initial state to an adjacent state, so a state accessible in one transition, times like whatever you're interested in. So F if probability of absorption, mu if mean time. So ito 1/2 F M1 to C2 because you have 1/2 probability to go from 0 to M1 and then to M1 to C2, which is technically accessible, right? If you go from here to here to here. So that's non-zero. 1/3 C1 to C2. So ito lang yan. 1/3 to C1 and then FC1 to C2. And then 1/6 because you have a 1/6 chance of going from 0 to S1 and then you get F from S1 to C2. So same problem, 4 unknowns but only 1 equation. So we add another one, M1 C2, and you get the following equation for that using the same process lang. So si M1 to C2, we get C1, so 1/3 C1 to C2, 1/6 S1 to S2, etc. The only thing of note here again is magka-cancel out to 0 because another state adjacent to M1 is M2. So 1/2 chance you go to M2. But M2 to C2 is 0. Not because you're already there, but once you get to M2, there's no chance to go to C2, right? Kasi stuck ka na dito absorbing state to. So meaning you can cancel that out to 0. So at this current situation, you have 2 equations for unknowns. Adding C1 to C2 will give you the following. The difference here naman for C1 to C2 is here at C1, so 1/2 M plus M1. So that's dito 1/2 FM1 to C2, and then you have 1/6 S1 to S2. S1 to C2, sorry. S1 to C1. Wait first. So we're at C1. We have 1/6 chance of going to S1, and then we're looking for S1 to C2, which is still possible naman. That's here. The only difference here is that you have FC2 to C2, right? Because you're here. C2 is adjacent, so 1/3 times FC2 to C2. This one naman is 1 because you're already there. So meaning, that's the difference between mean time and probability. For probability, if you're already there, it's 1. For mean time, if you're already there, it's 0. Right? Because since nandyan ka na, you're sure that you can get there, right? But it also takes a zero amount of time to get there. Kaya the mean time pag you're already there is 0, and the probability when you're already there is 1. So yan. Yeah. just the distinction between the two. And then for S1 to C2, this is the same procedure as M1 to C2, but starting from S1 naman, take all the ones that are adjacent to it, and then get F from the adjacent state to the one to the target state, which is C2. Same thing dito, magka-cancel si S2 to C2 because from S2 you cannot get to C2. So 0 yan. So now you have 4 equations for unknowns. Kasha yan sa calculator. And that gives you this number. So again, the one we're most interested in initially is F F0 to C2, which is this. So that's the probability that the coffees will win the tournament. Okay. Last one naman. How many games on average would it take the Sodas to tally their first win in the final round? Let me just zoom that in for the ones na walang copy. I believe Jerome sent a link. Also.
Yes, sir.
Thank you. Ayan. How many games on average would it take for the Sodas to tally their first win in the final round? So we're going from start of the tournament. So here at 0, Sodas to win their first round, S1. Recalling na we cannot. So this is like the time it takes to go from this state to this state. So even if let's say we forgot like yung theories natin on when it's applicable to do so this is mean time before first passage. Kunyari we forgot like all the theory behind it, right? Because sometimes that happens in exams. We can still figure out something. Kasi if you think about it, start ka dito. Kunyari, dito ka napadpad sa C1. So yung coffees nanalo sa first game. And then nag-win streak sila. So naging 2 wins in a row. Napunta ka dito. So this means na you can never get to here because in the thing you're modeling, tapos na yung tournament. So you can't have a number of games before they win first, right? Or before their first win, because they just didn't win in this specific run of the specific run of the scenario. So my chance na if they end up winning and never siya dumaan dito, the mean amount of time is indeterminate, right? Which makes sense. The theory behind that is just that if you have more than one recurrent classes, you cannot find the mean time before first passage. Actually, ngayon lang to in-email ni sir. But I clarified this with him. So I guess isingit ko na lang din. This is not, I believe, taught in class. Pero this is essentially like how you would generalize it. If you have one recurring class, the mean time before first passage, mean first passage time exists in all points. If you have 2 classes and then one is transient and one is recurring, it can only exist when the end state is in the recurring class. If you have more than 3 classes and more than 2 of them are recurring, this can only exist, the mean time before first passage can only exist if the start and end state are in the same class. So yan. You just have certain restrictions on what the classes can be. In this case, it's not sensible for you to have a mean first passage time here from here to here because there's a chance that you go here or like even something weird na like you go here, then you go here, and you go here. Pero dito ka pa rin mag-end up. No way to get to S1 from either of those points. So, magkaka-indeterminate ka, which means that you cannot get the mean time before first passage. So that's for problem 3. Okay. For problem 4, prove or disprove. For problem 4, ito. Prove or disprove the validity of the following statement. In any Markov chain with one absorbing state, say state K, in the long run, the process ends up at state K. No matter which state in the Markov chain the process begins in, and So basically, in any Markov chain with one absorbing state, in the long run, the process ends up at state k, no matter which state in the Markov chain the process begins in. This is false. Why? Because yes, there's only one absorbing state. But, medyo semi-trick question to. The problem doesn't say anything about recurring states or recurring classes, sorry. So for example, again, looking at the problem, looking at the wording of the problem, Markov chain with one absorbing state. So tama, this is one of the cases that the problem is talking about kasi this is one Markov chain with one absorbing state. But if you start at state B, C, or D, which is its own recurrent class, there's no way for you to get to K. Right? If you start here, like magta-travel ka lang between these two, like ikot ng ikot. But you're not able to go to K. Right? So this is like very, I mean, I guess it's a fair true or false question. Pero ayun nga, you have to like take note na the problem doesn't say anything about recurrent classes. So my case na isa lang yung absorbing state pero may recurrent class, di pa rin siya pupunta sa absorbing state na yan. Yeah. So that's for 4.1. So 4.2, you are the director of a new amusing park na Diva Land, where the 10 rides locations are named after the songs of by the 10 best-selling female music artists. Blank Space Mountain, Choo Choo Express Yourself, Don't Rain on My Parade Grounds, I Will Always Love You, Just Dance Hall, My Heart Will Go Kart, Pond Aeroplane, Swing Swing Bish, Turning Tabletops, and Vision of Love Boat. I do not need to read that now, in hindsight. Okay, whatever. 2 entrances. One is in the location of Ride D and Ride C. On the grand opening, the park has 10,000 guests. At the start of the day, 3784 guests enter through gate C. Everybody else enters through gate D. Because everyone enjoys the ride so much, you notice that no one leaves the amusement park. With this, you observe the patterns among the movements across different rides and you determine the following transition matrix, which is this. So it's quite intimidating because it's 10 by 10. Pero this is really just tedious once we get to it. So first, this is the drawing of the state diagram na sorry na lang sa like people who are trying to sabay. I'll just go straight to it. May recording naman. Pero ayan. Ito yung Markov chain. This is the state diagram of the Markov chain. So the first question is this reducible? If you look at it, you have essentially first like just low-hanging fruit observations. D is transient because there's no way to get to D from the rest of the state diagram. You'll also eventually observe na class CM is also transient because like yes, there's a way to get to them from D. But if you, for example, go from D to C and you go to like let's say I, sa loob ng I, there's no way to go back to C. Same thing with M because they're in the same class. They're the only ones communicating with each other two-way. Eventually, you also see that for BS, right? Kasi let's say you go from M to S, like you can bounce off each other. Pero the moment, for example, you go to J, wala ka nang magagawa. You're stuck in this state. You're stuck in this general area. Can't go back to BS. So those are the transient classes. And then you also observe na P and T are actually recurrent because, for example, go from D, go to T, maglo-loop ka lang. Same thing with M. From M, pupunta ka kay P, no way to go back to M. So maglo-loop ka lang. So recurrent din yan. J, I, V is also recurrent. I think we got a hint of that kanina when we found out na if you enter from C, there's no way to get out of here. If you enter from S, there's also no way to get out of here. So because you have multiple recurrent classes, this is in fact reducible. Yun lang yun. It's reducible. So, yeah. Yun lang. So, it's reducible. And then the proof for that is, as the problem says, dapat ibigay natin yung either transition matrix or state diagram. In this case, I gave the the state diagram, which is basically this. So, yeah. The only, I guess, semi-conceptual change here is na because you're now treating them as one state, you're just applying the property of recurrent states, which is that they always go back to each other. So, nag-add ka lang dito ng one na it'll loop back on itself. So, that's the only major change. We condensed them lang as such. So, as you can see, the probabilities, like let's say from C to I, that was 1/3. Same lang yan towards the whole class in general. Yeah, so that's the reduced Markov chain. So that's 4.2.1. 4.2.2. What is the mean time before someone who entered through the gate at C ends up in any of the absorbing classes? So this is just mean time before absorption, which is from C DAO specifically. So UC. Okay. So same procedure from UC. What are the states adjacent? It's just mu M and mu IJV. So I mu just M and IJV. So we just get mu M. So 2/3, 2/3. So mu M, and then 1/3, right, mu IJV. But again, mean time before absorption. If you're already in an absorbing class or absorbing state, edi 0 lang yan because you're already there. So I just the fuck. Okay. I just applied the same logic for 4 equations. So same thing, same rationale as to the order of which I added equations. This is one equation, 2 unknowns. What?
I think napindot niya.
Oh.
Jokes.
Oh.
Okay.
Game. Sige. Mu M. So one equation, 2 unknowns. Let's try to express mu M on the left hand side, which is as follows. Yeah, I think sige, I'll still explain it para what talaga. 2/5 M to C 2/5. So M to C is 2/5, so 2/5 and then mu C. Same thing dito, 1/5 from M to itself. I guess this is this is a bit new in the review session. So if nag-loop back siya on itself, like retains in state M, you still have to write it. So maga-cancel siya eventually. But yeah, or not cancel, it'll just like subtract from itself. Pero it's still important to list it down, even if it loops to itself. Tapos 1/5 M to S. And then connected siya to PT. So 1/5 as well. M to PT. Mu PT is just 0. So that's our second equation. So made the problem a bit worse, no? Because it's now like 2 equations and 3 unknowns. So still relatively difficult. But now let's add mu S. So now we have okay. Baka unmuted lang. Now we have mu S. So adding that, nag-expand siya ulit. Nagkaroon pa tayo ng mu S and mu B. So now it's 3 equations, like 4 unknowns. So yung hindi pa natin na-express dito is mu B, right? Wala pa siya sa left-hand side. Let's add mu B. In this case, it added one more equation but no new unknowns. So thankfully, that means we have 4 equations, 4 unknowns. Again, pwede to sa calc, diretso. Thankfully. So, there we go. Mu C, mu M, mu S, mu T. This is just from calc. Yeah, the only challenge here talaga is transposing. Just be very careful. So, it's either the case na ita-transpose mo to dito, magkakaroon ka ng negative. And if you lay it out correctly, it's gonna be a diagonal of negatives. Not always negative 1, because in this case, for example, transpose mo yan, magiging negative 4/5. Or here as well, negative 4/5. Here also. But yeah, tas magiging negative yung 1. That's my suggestion. Or you can also move everything else. So lahat ng ito magiging negative on the left-hand side. Tas ito positive, ito 1. Basta, this should be relatively straightforward unless they make it like 1 million equations. So yeah, just be very careful when you transpose. These are the values that you get when you input it sa calc. The one we're most concerned with is the amount of time before someone who enters from gate C ends up in any of the absorbing classes. So that's this one, 3.6875. So yeah, that's the 4.2.2. 4.2.3. In the long run, what is the expected number of people that will be in the class where ride I belongs to? So, it's this one. So essentially, steady state yung hinahanap dito. Ay, sorry, not yet. Probability of absorption pala muna. Kasi I did these both simultaneously na. Tas in the long run, what is the expected number of people that will be in ride I? Kasi medyo related naman sila. But let's start first with the first step. The part that like class I belongs to. So same thing. Here's our transition. This is our state diagram ulit for reference. So our main interested one is FD to IJV. So wait. Yeah, so dalawa yung interested tayo. FC to IJV and FD to IJV. But the reason why I chose FD to IJV first is because when you express FD to IJV, so you have just like stick with me for a bit. 3/10, diba? So 3/10 to D. So D to IJV. And then you realize na C is adjacent, C is accessible by D. So you can also have 3/5 FC to IJV. So instead of doing this procedure twice, you only have to do it once kasi kasama na si FC to IJV if you start with D. This is not the case if you first start with C kasi C is not accessible. D is not accessible from C. Right? There's no way to get if you try. There's no way, di pwede dyan, di pwede dito na area. No way to get to D. So I to D from C. So I just started with FD to IJV muna. I think sa quiz this also became useful. Di ko siya ginawa. So di ako natapos. But yeah. Never again, I guess. Hopefully. So ayan, FD, IJV. This is the expression for that. The only notable thing here is that FT to IJV is 0, right? Because 1/10 here, T. Can't get to I from T, IJV from T, kasi this is a recurrent class. Actually, I guess it would be more correct to put this as PT. Yeah. Just for like correctness. Kasi I think magbabawas sila ng 0.5 like for that. So PT. Ayan. So same process lang. Dito naman since na-try na natin to. So these are already expressed. Let's try this one, like adding this one kasi it's right now one equation, two unknowns. So adding one more equation, FC IJV. So that's from here. You have I, Fi, well, technically Fijv to Ijv. So, that becomes 1, right? Kasi magiging 1 to. So, effectively, this term becomes 1/3 because you're already there. So, probability is 1. Fm to Ijv. So, ito lang yan. 2/3 because 2/3 yung probability to go from C to N. Yeah, so now, we have 2 equations, 3 unknowns. So, adding Fm naman, Ijv. So, 1/5 back to itself. And then 2/5 Fc to Ijv. 2/5 then C to Ijv. And then 1/5 Fs to Ijv. 1/5 Fs. And then PT, 1 FPT to Ijv. So, 0 ulit. This brings us to 3 equations for unknowns. Yeah, 3 equations for unknowns. So, I added Fs lang, Fs to Ijv, which gave me this expression. So, naging 4 equations, 5 unknowns. And then, so I added Fb, Ijv. Then, naging 5 equations, 5 unknowns. So, in this instance, this is more than 4. Hindi siya automatically agad magawa sa calculator. So, you have to be a bit more creative. So, we can start by taking a subgroup of these equations that we can solve internally without needing the other ones. So, another n equations and unknowns na subset inside. So, intuitively, I get, in a way, kasi madali lang siya makita when you sort it like this. Itong 4 and 5, 2 equations, 2 unknowns, na separate sa iba. So, we can solve for 4 and 5 together muna as a system of 2 equations, 2 unknowns. And this will give us this. So, medyo weird, no? Because it's 1. But why is it 1? Because, if you look at it, this is them in one class, right? There's no way for S to go to any other place except B. So, maglo-loop lang sila, loop ng loop. Then, they end up in J, right? So, in the IJV class. If you look at it, if you think about it, this makes sense because we already saw before na B and S are transient classes. Meaning, the probability that they will be absorbed, the transient class, yung probability of absorption ng transient class, the states in a transient class is always 1. Because that's the definition of transients, right? Like, the implication if may chance na hindi ka babalik is that in the long run, hindi ka talaga babalik. Like, once you do it, like, infinite amount of times. So, meaning, this makes sense. This is what we got from doing the equations unknowns thing. And this makes sense. I guess if na-spot niyo agad na this just becomes 1, that's also fine. Like, if you use concepts, 1, 1. May 1 to lahat. But yeah, in our case, di ko siya napansin. So, I guess it's also just a more reliable mechanical way to do it. So now we've brought it down, removing these 2 equations. Babalik tayo sa original 3. Initially, diba, 3 equations for unknowns to. But we've solved for Fs, comma Ijv. Meaning, we've brought it down because we have information on what the value of this is. 3 equations, 3 unknowns na to. Meaning, wait, let me just... Is the recording still alive? Or is like the streaming still alive? Kita
Yeah,
pa
you're
rin.
good. You're good.
Oh, thanks. So then, 5 equations, 5 unknowns. Okay, so now, it's down to 3 equations, 3 unknowns. So now this is solvable. And once you plug it in sa calc, these are the values that we get. So from D to IJV, 9 out of 14. C to IJV, 3 out of 4. And M to IJV, 5 out of 8. Yung tinatanong specifically is, what is the number of expected people at RIDE-I? Ito na yun. Kasi some amount of people, so what are these two? Recall lang na there are 3784 people who entered through gate C, right? That's here. 3784 guests entered through gate C, and then sorry. Then the rest entered through gate D. So that's 6216 minus lang. So the amount of people who will go to the class where ride I belongs to is 6384. Okay. Next na tinatanong is how many yung pupunta sa kay ride I specifically. The way we do that is we just break this down. So, diba, this is a recurring class. This means that within this class, there's a way to break down the number of. There's a way to get steady state probabilities within the class. As long as we're only referring to here, like with respect to this part, we can get steady state probabilities even if there are recurrent classes. So what this looks like is, so alam nating 6834 yung papupunta dito. We can now essentially treat I, J, and V as their own classes. Right? So then this is 1/5, 3/10, 4/9, 0, 0, 2/9, 4/5, 7/10, and 1/3. Okay, adds up naman. Oh shit, wait, let me fix my pen. Okay, so this is the transition matrix. And this is basically consistent with what we have here. Ito na part. Okay, and then so getting yung multiplying this with yung what you call that transition matrix mo. So pi I, pi j, pi. So your steady state matrix here. So when you do that, yung lalabas is you have 1/5 pi I plus 3/10. Sorry guys, this pen is, I have to replace the tip pa. 4/9 pi v equals pi I, right? Because this is equal to basically. Okay, and then you have 2/9 pi. Oh my god, 2/9 pi v is equal to pi j, and then you also have, well, sobra na siya, pero you can still, for the sake of completeness, 4/5 pi I plus 7/10 pi j plus 1/3 pi v equals pi j. So if you actually use these three equations, three unknowns to you'll actually get infinite solutions sa calc. I guess it's also one way to check if you inputted everything correctly. Yeah, if you input it without the normalizing equation, it will spit out infinite solutions. So you have to add the normalizing equation equal to 1. Yan. So using any two of these, the three equations here. Shit. Wait, sorry. Oh my god, what the fuck? Wait lang. Using any two of the three here, and then this one, you can basically, like, pwede mo lang siyang i-calc. Because it's three equations, three unknowns. At the end of this, you'll get pi I equals 23/67, pi j equals
8 over 67, and pi v equals 36 over 67. Okay. Yep, that adds up. So, we're concerned lang with how many guests, long run, amount of people in Red Eye. So, ito lang yung concern natin. Essentially, if you look at the bigger picture, na may nag-enter na guests at at gate C, at state C and state D. We found out from the previous sub-problem that 6834 of those guests have ended up in this recurrent class, this part of the theme park, right? Di na tayo concerned with what happened to the other one that makes it 10,000, pero conceptually the rest just went here. All we know, but what we care about is this, because itong 6384 na to, hahatiin mo yan further based on this based on the steady state probability, which means 23 over 67 of the guests, the 6834 guests that you know are at IJV, as the subsection of those 23 out of 67 at any given time on average will be at Red Eye. So that's 2, 3, 4, 6. So that's your answer for the number of people at I. Yeah. So, yan. Last problem. Last sub-problem. As the day passes by, you notice that the vision of Love Boat, so that state V, is experiencing some technical difficulties and may need to close for the rest of the day. Because you try to bring something new to the moment, you think of holding a concert in the middle of the day. There are just 3 locations in which you have a concert. Locations: Don't Rain on My Parade Ground, State D, Just Dance Hall, State J, and Ponder the Plain, State P. You know that all 10,000 guests will go to the concert, wherever it's located, and after the concert, the guests will start following the transition matrix, beginning from where the concert is located. Now your decision is to select among the locations would be the best place to have the concert, so that afterwards, the least amount of people settle in the vision of Love Boat Ride. Which location among the 3 will you choose and justify your selection? So, this does not require solving na, just requires some intuition. So, yung sira dito is ito, si State V. We want as little people to go to State V. The problem presupposes na when you hold the concert, they will go to the concert wherever it's located. So, pili tayo between the three state options: State D, State J, and State P. So we want the state that will give us the least amount of people na pupunta. So looking at it visually lang, from State J, 10,000 people here. So many yung pupunta kay State V because so kasi V is accessible from State J. From State D naman, I guess intuitively, like looking at it, mukhang less people will go. Because right, it can either go to here or here. Pero may chance pa rin na you have people, like if they take various paths, they'll end up in State V pa rin. So it can still happen. But, I guess, like from hunch, probably less than State J. If we take State P, can only go to State T, diba? Cycle lang yan. So, actually, if we put the concert in State P, there's 0 chance na makakapunta sila from State P to State V, which is what we want. We want to minimize the number of people going to that place, going to State V. So actually, I guess if there are multiple choices, so like let's say it was just State J or D, you'd have to solve it, right? Because may chances na pumunta sila kay State V. So you have to prove mathematically na less people will go from D than like J. Pero in this case, since alam nating 0, like yung chance of getting from P to V, we can just immediately conclude without solving, just by intuition. Or just by using concepts that we know about, like accessibility between states, given that there are two different recurring states, that P would be the best option to contain the people, make sure they don't go to state V. So yeah, final answer is state V. Wait, I'll just write that down when I give it out. Okay. Yeah, so that concludes this exam. I guess this one is a bit longer because it's one of those pandemic exams na 48 hours. But yeah, hopefully even like, I do understand na it's not like, probably not gonna be present exam difficulty. So the department is like that. Pero ayun, I hope this has been somehow useful pa rin. So I guess I can take questions for a bit. And then I will let Sina AJ do their documentation thing. And then we can call it a night. If there are people typing pala sa chat, for some reason, hindi nagbubukas yung chat dito. Like, I cannot scroll it for whatever reason. If people have been typing, I'm sorry, hindi ko siya kita. Just message here sa regular text channel. Yeah. Sige. I'm assuming there are no questions. Or if you guys are thinking pa, AJ, Roque, you guys can do your thing.
AJ, can you show the evaluation? Sorry, the feedback form. So guys, quick lang. Can you just answer the feedback form? We will be flashing the QR code now. Wait lang. AJ, sorry. Um, okay. We'll just send na lang the QR code in the Clubber Ahad Welfare channel in Messenger. So please do fill that up. Thank you.